Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about covalent bonds and how we can draw Lewis structures using our Lewis dot symbols to convey the idea of sharing of electrons. So in a previous video I had talked about how you could use Lewis symbols to create Lewis structures for ionic compounds with a transfer of electron from one element to another, but here we're going to talk about sharing electrons because covalent substances will share those electrons. So we're going to talk about single and double and triple bonds. So here are a couple of examples. So I have water and chlorine gas, chlorine diatomic molecule. So the thing you want to keep in mind is we're going to write the Lewis symbols for all the atoms. So if we start with water, so we'll have oxygen. And so oxygen, again, has 6 valence electrons because oxygen is in group 6. So we're going to have 6 valence electrons. So we have 1, 2, 3, 4, 5, 6. And we have 2 hydrogens. Each hydrogen is in group 1, so it has 1 valence electron. So we'll draw the hydrogen here, we'll draw 1 here and 1 here. You'll see why in a moment. And so each of them have a valence electron. So I will put 1 there and 1 there. And so at this point, there is no transfer of electron because both oxygen and hydrogen want another electron. Hydrogen needs 1 more electron to fill its outer shell to be stable like a noble gas. And oxygen needs 2 more to be stable like a noble gas. So the only way that they can be satisfied is that by sharing. So what you're going to do is you're going to pair these up. So these 2 unpaired electrons get paired up, and these unpaired electrons get paired up. So it's all about pairing electrons. Whether you're making an ionic Lewis dot structure for an ionic substance or a Lewis dot structure for a covalent substance, it's always about pairing up unpaired electrons. Either you're going to transfer the electron to pair up with another one, or you're going to share the electrons so they get paired up. Okay, so here we pair them up, and so what you end up getting is something like this. If I rearrange it, maybe I won't rearrange it, I'll just keep it like this. So I have hydrogen here. So these 2 electrons are being shared between the oxygen and hydrogen. And then these 2 electrons are being shared between the hydrogen and oxygen. And notice I rewrote the dots to fit with the Lewis dot structure. So they're straight in a box, not like this. And then you have the 2 lone pairs. You have lone pairs here that are not really bonded anything. So right off the bat, what I want to talk about here and here, these 2 are called lone pairs. Electron lone pairs. They're not bonding. So they're also called non-bonding pairs of electrons. So the electrons that are between atoms, these are considered bonding pairs. So you have non-bonding pairs, or lone pairs, and you have bonding pairs. So this would be the Lewis dot structure for oxygen. Another way you can do it is, instead of having the dots in the middle, the way I prefer to do it is just, you can replace those 2 dots with a line. And that line will represent the 2 electrons. So you can write it like this. So another way you can write it is this way. And so you'll notice that I replaced the pairs of electrons, the dots, with a line. So you just need to understand that each line represents 2 electrons. You can't have a bond without 2 electrons. So here's a bond. And, well, technically you can't have sort of a bond with 1 electron, but we're not going to get into that. So here you have 2 bonds, so 2 electrons in each, and you have 2 lone pairs. So the octet rule is favored. So you can see the octet rule here as well. You got the 8 electrons. And so the other thing I want to point out is you'll notice that I moved the hydrogens here and here. It doesn't matter where the hydrogens are. So this is the correct Lewis dot structure. This is the correct Lewis dot structure. I could have wrote it like this too. I could have said, I could have done this. So that's perfectly fine too. So it doesn't matter as long as you've got the correct number of dots and the correct number of lines, and everyone's happy with their octet or a duet. If you're talking about hydrogen, then this is fine. So this is how you would write the Lewis dot structure using Lewis symbols for your elements. So let's look at chlorine. Chlorine again. So we have 2 chlorine atoms. So let's go ahead and put them around. So we're going to do, we're going to go counterclockwise. So we have 1, 2, 3, 4, 5, 6, 7. So it has 7 valence electrons because it's in group 7. And then I have another chlorine. So I have 2 chlorines. And so we're going to go around this way. 1, 2, 3, 4, 5, 6, 7. And so each of these, again, wants an extra electron. They both want an electron to be satisfied, to get their octet to be stable. So there's not going to be a transfer. So they're going to have to share. So then these 2 unpaired electrons get shared between both atoms. So the way you can write this is that Cl with the 2 dots in the middle, and you have the 3 lone pairs around here. So you have 3 lone pairs around here. So this is the Lewis dot structure for chlorine gas, so Cl2. Again, I can replace those 2 dots with a line, and that's going to be perfectly fine. So Cl line Cl, and then I have my lone pairs. I have 3 lone pairs around each chlorine, like that. So you'll notice each of them have a single bond. So 1 bond, 1 bond, 1 bond. Each line represents 2 electrons. So a single bond is just 2 electrons. But what about double and triple bonds? Okay, so let's start with oxygen. So here, oxygen is again a diatomic molecule. So if we have 2 oxygens, right? We were going to write the symbol for both of them. So here, we'll do 1, 2, 3, 4, 5, and 6. And then we'll do this one. 1, 2, 3, 4, 5, 6. Both of them have 6 valence electrons because oxygen is in group 6. And so now both of these need an extra 2 electrons. They both want 2 electrons. This has 2 electrons to give. This has 2 electrons to share. So we're going to pair up those unpaired electrons. So these 2 get paired up. And then these 2 get paired up. So there you have 2, that's your double bond. So you can write it like this. So you could do this. You could have both pairs in the middle. So you can have your 2 oxygens with both pairs in the middle. And then you have your 2 lone pairs on each oxygen, like so. So you got your double bond because you got 2 pairs, and you got your double bond. You can replace those with lines. So you can write it like this. You can have 2 lines, and then you have your lone pairs, like so. And so either one of these would be the correct Lewis dot structure for oxygen molecule. And so you'll see you have a double bond. So you get the double bond because both of these have 2 unpaired electrons that want to be shared, and you're sharing them both between 2 atoms. Okay, so what about nitrogen? Last one, nitrogen, probably going to be a triple bond. So let's see. So we have nitrogen, and we have nitrogen. So nitrogen is in group 5. It has 5 valence electrons. So let's see what happens. So we're gonna, let's see, where should we start? That's gonna be best. All right, we'll start here. So we're gonna go around 1, 2, 3, 4, 5. So that's 5 electrons. Here we'll go 1, 2, 3, 4, and 5. So you'll notice that both nitrogens love to have, they have 3 unpaired electrons, they have 5 valence electrons. So 3 unpaired electrons, so they're going to want to pair up 3 of these electrons. So to form this, you can pair these up, you can pair those up, and you can pair these up. So you got both unpaired electrons here are paired up. So that's going to give you 3 bonds. So you got 3 pairs. So you could write it like this. So N, you have 1, 2, 3, like that. And then you have the other N. And then your lone pairs are here. So that would be the Lewis dot structure for nitrogen. And again, you could replace these with 3 lines. So this would be also good. This is the way I prefer to do it, and a lot of people prefer to do this. It's just easier to write, and it's quicker. And writing dots all the time can become cumbersome and kind of monotonous. So here you can just do 3 lines, and each line represents 2 electrons. So you got to remember there's 6 electrons here, and then you got 2 here. So 6 electrons are being shared. So you have 6 electrons belonging to this nitrogen, and it has 2 electrons in this lone pair. So that's 8, and the same thing for this one. So that's 8. So they're happy with their octet. Okay. There's something else I wanted to say before I end. Okay, so this is your triple bonds and your single bonds and your double bonds. These are the way you write the Lewis dot structures. I think that's it. I hope you enjoyed this. If you got something out of it, please share it with your friends. Hit the notification bell so you can be notified by other videos I put out. Make sure you hit the subscribe button, subscribe to the channel, and make a comment in the comment section. Let me know what you think and if you have any questions. And it also feeds the algorithm. So thank you for joining me, and I'll see you next time.